All right, so the formal definition of the derivative, there are two different forms that you could see this in. One is the limit as h approaches 0 of f of x plus h minus f of x all over h. Or the alternative form is the limit as x approaches a of f of x minus f of a all over x minus a. And both of these are the formal definition of the derivative, meaning they will find the derivative, and we can use this before we knew our nice shortcuts, or if AP happened to give us questions like the following. So 37 says f is a differentiable function. We can have a derivative. Therefore, the derivative is given by which of the following? So which of these match my formal definition and derivatives up here? I like this first one. Instead of x, they just used a, but option 1 definitely applies. Option 2 is the same. The problem with option 3 is that they're having x approach a, but using my initial formula, so it's almost like they put the two together and it doesn't work that way. So I like 1 and 2, and that would give me answer C. On 29, they're asking for the derivative without saying anything. So they're asking what is the derivative of the function. And what we need to be able to do is extract what the function is. So we are using this definition of the derivative as h approaches 0. So my function is f of x. So in this case, my function is the tangent of 3x. That's my function. Go ahead and get the derivative of that. Do not forget the chain rule. The derivative of tangent is secant squared of 3x times the derivative of 3x, which is 3, getting me an answer of B. Okay, on 10, we're going to do the same thing. We need to extract the function and find the derivative of it. Again, they've used this definition of the derivative. Therefore, the function is sine. Don't be confused with the negative. That's just part of the formal definition. So my function is sine. The derivative of sine is cosine. 25 varies a little bit. It's still using the same formal definition, but here the function, we need to know the function is the sine of x. The function is the sine of x. The derivative of sine is cosine, and what this is actually asking now, okay, the derivative of sine is cosine. Now they want to know the derivative at that x value of pi over 3. So now I'm going to say, all right, f prime of pi over 3 will be the cosine at pi over 3. Thinking to my unit circle, we've got pi over 6, pi over 4, pi over 3. These coordinates are 1/2 root 3 over 2. Therefore, the cosine is the x value, which is 1/2. Okay, I figured I'd keep the derivative rules close by, a formal definition of the derivative definitions here. In 25, it's saying if the function is e to the x, what is the derivative of the function at e? But notice that they aren't just straight up asking for the derivative. They want you to put it in the form of the formal definition of the derivative. Because my h is approaching 0, we're looking to use this formula. They want when my x value is e. Okay, they want my x to be e. So when we go ahead and plug this, get a pen here, when I apply this definition, my x is e, so I'm going to have e plus h plugged into my function, minus my function, which would be when x is e all over h. Okay, well, if when I plug in e to the h to my function, correct me if I'm wrong, but that would be e to the e plus h minus e to the e all over h. And when I look at my answers, that matches option E. Again, can we extract the function in question 6? And in question 6, the function is going to be 8x to the 8th. And what they want is they want the derivative of that function, which would be 64x to the 7th. Then they want the derivative when x is 1/2. And that means we'd have 64 times 1/2 to the 7th. 1/2 to the 7th, when I multiply 1 times 1 times 1, we obviously get 1 on top. 2 to the 7th. 2 times 2 is 4, times 2 is 8, times 2 is 16 times 2 is 32, times 2 is 64, times 2 is 128. And we'll be left with 64 times 128, which is a half. All right, on 8, it says the formal definition of the derivative is 0. Which of the following must be true? Well, what this is telling us is that the derivative when x is 2 is 0. I agree with C right off the bat, but let's go ahead and go through why it's not the rest of the answers. The limit does not exist. Well, that's not true because they're telling us the limit is 0. If the function is not defined at 2, that means it's not continuous and therefore cannot have a derivative. And if they're telling me the derivative is 0, then it does have a derivative, therefore it must be defined. Does it have to be continuous at 0? We don't know what's going on at 0. All we know is that the derivative at 2 equals 0. We don't know if it's continuous at 0. We don't know what else is going on with the function. Just like with D, I have no idea if the function has the point 2, 0. All I know is when x is 2, the slope is 0. So I like C. Ooh, 17 goes back to derivatives of inverse trig functions. Whoa. So the function in this case, we know my function is inverse sine of A. And we've got to remind ourselves the derivatives of inverse trig functions. The derivative of inverse sine is 1 over root 1 minus the angle squared, if you will. And in this case, it says which of the following could be a value of A. Well, what they told us is that the derivative is 2. So we found the derivative. We need to say, all right, for what value of A would this derivative be equal to 2? I'm going to go ahead and cross multiply and I get 1 equals 2 times this root. I'm going to divide by 2 and get 1/2 equals the square root. I'm going to square both sides and I'd get 1/4 equals 1 minus a squared. I'm going to move my a squared over, subtract my 1/4 and get 3/4. And finally, I'm going to take the square root of both sides to get root 3 over 2 would be my value for A.